All right, let's try to make chapter 2.5 on transformations just as simple as we can. There are a few basic graphs that it would be just nice if you kind of knew the shape of them. So when you see the square root of x, I always tell my students it looks like an eyebrow. So it kind of looks like this. And it's just nice to know what the shape is. So if you ever see that shape, see how it looks like an eyebrow? It's the square root of x, okay? X squared looks like a parabola that opens up. Okay, if you don't see any negatives or anything like that. So it's a parabola that opens up. So what I tell students to do, if good idea, take an index card, put this on one side of your card, put this on the other side of your card, and kind of quiz yourself. Look at this and be like, ooh, what graph is that? And be like, oh, it's x squared. Okay, and go both ways with your cards. X to the third, it looks like this. It always goes through the origin. Whoops, I'm looking through my phone here. We're doing this real quick before I leave for work. And it looks like that. Okay, so that's kind of the x to the third graph. So you want to know that one. Absolute value of x is a sharp V. So make sure you know the difference between the parabola, which is a nice smooth curve, and the absolute value, which is a real sharp point. Okay, U, V. There's a difference. Okay. The cube root of x kind of looks like this one, except he's laying on his side. Notice the square root of x is an eyebrow. So it's very similar to that, okay? So it kind of looks like that. But then you've got this part that also goes down here. So you have two sides of the graph on the cube root of x. And the only other one you probably should know is 1 over x. And we'll be doing some more of those later. This is an interesting graph, and it's split. It kind of looks, we'll be discussing this more in later chapters, but it's got something like here. And what it does here is it hugs the y-axis here, and over here it hugs the x-axis. And then it does the same thing over here. It's kind of like the little reflection over here. So that's what that graph looks like. You will not see that one as much on this chapter. Okay, so this is the standard graph that you always start with. All right, now you could plug in points on these if you so chose. Like when you say, what do you mean plug in points? Well, you guys are familiar with your t-chart. Remember, this y is the same thing as this f of x, exactly the same. So note if I put 0 in for x, the square root of 0 is 0. Okay, if I put a 1 in, the square root of 1 is 1. I would stick, you can plug in anything you want, but I don't want to plug in like fractions and stuff like that. I don't want to graph them, so I'm going to pick perfect squares. So pick anything you want. If I put in 4, the square root of 4 is 2. And then I could plot these points right here, 1, 2, 3, 4, 1, 2, and you can see it, there it is. There's 0, 0, there's 1, 1, there's 4, 2. You can see if I plug in 9, the square root of 9 is 3. I could do that with every single one of these, okay? But it's still just nice to know the basic shape. So how do transformations come into play? Well, let's just start with one. Let's say you have something like this. Now, what I see is something squared. So when I see that squared, I'm like, oh, I know what that looks like. Something squared is always a parabola. So I already know that my basic shape looks like this, okay? Now, notice this is messing with my x, and I tell students if it messes with your x, it messes with your mind. So you would think that, you know, your x-axis is right here. And x is always a horizontal shift. It goes back and forth. So you're going to do the opposite. You would think if you would add 2, you would take this graph and you'd march to the right 2, but you do the opposite. I know it's crazy, but you're going to go to the left 2. So it's actually going to be right there, and so my graph's going to look like this. Okay, it's a parabola, the exact same parabola, but it went to the left 2 units. Okay, again, if you don't believe me, you can always do the t-chart. Now, instead of this saying xy, I could put xg of x. Who cares? Remember, these are the same thing. But notice if I put 0 in here, put anything you want for your x. Remember, he's independent. 0 plus 2 is 2. 2 squared is 4. So look at here. 0, 4. 1, 2, 3, 4. I mean, I should have my point right there. Okay? Notice if I put in a negative 2. Negative 2 plus 2 is 0. 0 squared is 0. So notice I've got the point, negative 2, 0. Okay, you could do that for as many points as you want. There's infinitely many points on here. I always tell students to find 3 or 4 so you can get the basic idea, okay, of how to graph it. So notice if I had this graph, let's do this one. My cat's gonna come up here and be obnoxious. Okay, this is absolute value. I see absolute value signs and I'm like, oh gosh, I know what that looks like. Look, it's a sharp V. So I already know on my graph I have a sharp V. Okay, and I am sketching these out fast, okay? But it's inside, it's messing with my X. It's not like something over here on an afterthought, okay? It's messing with my X. Remember, if it messes with the X, it messes with the mind. It does the opposite. So you would think this goes left 4, you know? That's what you would think, because you're subtracting 4, but it does the opposite. You're gonna go right 4, 1, 2, 3, 4 units. So this origin right here, just slide him over 4 units, and your graph's gonna be exactly the same. Still a sharp V, still exactly the same, except you just slid it to the right 4 units, okay? Now, we're gonna do some more like that here in a minute, but that's if it's messing with that. Now, what happens, and by the way, that would have been the same thing if it would have been a parabola or any of these, okay? Like, let me do one more, and I'm just making up letters. You can make these anything you want. Let's say I would have had the square root of, let's do this one, x plus 2. Let's go over here. Let's do a minus 4. Let's add something over here, okay? So, I start here with my graph. I see a square root symbol, and this is where it's nice to know what the graph of square root looks like. Well, I'm like, square root, oh, that's my eyebrow, okay? So before I shift it, my standard graph looks like this. I'm gonna dot him out right quick, okay? Now, this one tells me that I'm gonna go left 2. It's inside, it's messing with my X, so it's gonna mess with my mind. So I'm gonna take this point right here and I'm gonna go left 2, so I'm kind of right there. Now this is on the outside. This messes with the Y, okay? This is an up or down because I know my Y axis goes up and down, so this tells me this goes down 4. So this guy right here tells me it goes left 2 and down 4. So I'm gonna go ahead and just do 4 tick marks right here. So I'm gonna go left, start with your origin. I'm gonna go left 2 and down 4. And let me just say, that does it with every single point. There's infinitely many on here. So if I just sketch this out, I know it's gonna look like that, okay? That would be my basic graph. So if I just had to pick multiple choice and I'd be like, I don't know. Okay, let's say you had to graph it exactly though. Let's say you were on the test and I'm like, hey, show me at least 3 points. And you're like, oh my gosh, you know it's gonna look like that. Okay, so I'm like, okay, this is X, this is my J of X, or your Y. You can plug in anything you want over here, as long as it's, you know, defined. You can't plug in negative, you can't take the square root of a negative number. Now notice I can plug in -2, because -2 plus 2 is 0, so I can plug that in. The square root of 0 is 0, and 0 minus 4 is -4. So you're just, use your calculator, okay? Your calculator should be able to do this for you if you don't like to do that. But look, there's the point, -2, -4, okay? So let's try another one. Now remember, I can plug in anything you want. If you're using your calculator, decimals will work, okay? I'm not using a calculator, so I'm gonna think ahead. I know I can take the square root of 1, so I'm gonna plug in a -1. Because -1 plus 2 is 1. The square root of 1 is 1. 1 minus 4 is -3. So look, I've got -1, -3. It's right there. And you can see it, -1, -3. Okay, now I could plug in 0. 0 plus 2 is 2, but I don't want to figure out the square root of 2. He's ugly, but I could do it. You could use your calculator and approximate. That would be fine. I do know I can take the square root of 4. So I'm thinking ahead. I'm going to plug in a 2 right there. Why a 2? Because 2 plus 2 is 4. I know the square root of 4 without using my calculator. The square root of 4 is 2. 2 minus 4 is -2. So I'm going to check over here on my graph. 2 is about here. And look, there's 2, -2. Look at that. Okay? And I could keep playing. I mean, if I wanted to plug in a 7, you're like, why a 7? Plug in anything you want. If you got a calculator, go for it. And then just give me the decimal answer here. But I'm not using a calculator. 7 plus 2 is 9. Square root of 9 is 3. 3 minus 4, -1. So if I'm going to come way over here, 1, 2, 3, 4, 5, 6, 7, -1 is about there. So I can see if this keeps going on forever and ever. See that arrow? So I can tell it's going to be like right there. Again, kind of a flat eyebrow. He's going up. So let me just say real quick, let's do another one. Let's add another transformation. Let's do x to the third. So we'll go back to, how about a k of x? Who cares? Make up whatever letter you want. So I'm gonna do this guy. I'm gonna start with this guy, but let's look at him. Let's go x minus 1, and we're talking cubed, and then let's go plus 5, okay? If I had to list out my transformations, remember, if it messes with the x, it messes with your mind. You're subtracting 1, crazy, but you're gonna go right 1 unit. This is just what you see. That's a vertical shift. It messes with the y, and it's gonna go up 5. So I would be like, okay, show me what you've got. I know this, my dotted one, that's the standard for x to the third, okay? I always start with my origin, okay? It's just easy to work with. I know I'm gonna go right 1. Remember, we do what's in parentheses first. So I'm gonna go right 1, and then I'm gonna go up 5. 1, 2, 3, 4, 5. So I'm gonna go right 1, up 5. So this point right here just shifted here. So I still got this basic shape right here. It's gonna look just like that. And again, I could plug in as many points as I need and find him exactly, but I know he's sitting up here. He's just kind of gone up a little bit. Okay, so that's the basic ones right there. Those are your vertical and horizontal shifts. All right, let's look at something else. Now, what if all of a sudden I get a negative out here, and it's x plus 2 squared, okay? Now, for the first time, I've got a negative out here. Well, I see this as x squared, so I know it's a parabola. I know I work inside parentheses first, so I know he's gonna go left 2. So now I've got a parabola that looks like this, okay? But all of a sudden, I've got a negative on the outside. If it's on the outside, it messes with the y. And I'm just gonna tell you, this guy makes him flip upside down. He's going to reflect across the x-axis. Okay, so he's gonna look like this. Okay, I made him too fat, but it's taken, I'm looking through my phone. It's gonna take this parabola and throw it upside down. So this makes him flip upside down. Makes him, this is your x, so he reflects across that. What that does is it changes all your y values. So like, for example, let's find a point. Well, I'll do that here in a minute. I just want you to know if it's on the outside, it flips it upside down and it will change the sign of the y, okay? So for example, if I had, I'm just making up a point right here. Let's say I had the point 2, 4. If you reflect it down here, notice that would be the point 2, negative 4. If you flip it upside down. So notice my x stayed the same, but the y changed the value. And we'll look at that some more here in a minute. Okay, so let's try another one. Let's just go back to this. Who cares what I'm using here? Let's do a negative. Let's do x plus 5 minus 3. And in fact, I'm gonna put a 2 out here for the first time. That's on the outside, okay? So again, I'm just making up graphs really quick to hopefully this will help you see this. Okay, I see a square root symbol, so I'm like, gosh, I know what that looks like. It looks like an eyebrow, okay? So I know to do order of operations, treat this like it's parentheses, okay? It's a square root symbol, but do what's in here first. So we're gonna go, it's adding 5 to the x. Oh, if it messes with the x, it messes with my mind. So I'm gonna go here, left 5. 1, 2, 3, 4, 5. So I'm right there. That makes it flip upside down. So now, instead of being an eyebrow like this, I see that negative sign. I'm like, oh, he looks like this. See how he flipped upside down? And then this makes him go down 3. Now I'm gonna ignore him just for a minute. And so I'm gonna go down 3. 1, 2, 3. So here's my point, and I'm gonna go down 3. So my eyebrow should look, whoops, maybe kind of like that. I'm running out of paper, but he's going down. What does that 2 make it do? Well, it's on the outside. If it's on the outside, notice he's not here, it makes it do, messes with the y. So what it's doing is things are happening twice as fast. So if it was a parabola, it's gonna go up twice as fast. This is gonna go down twice as fast. So he might look more like that. You know, he's just gonna go down a little faster, and you're like, I don't get it. Fine, that's okay. You know what? Do your T-chart, find a couple points till you can see it. I'll tell you what I plug in first here is I plug in what makes it 0. You can plug in anything you want as long as you don't end up with a negative under here. So I'm gonna plug in a -5. I chose that because I can see -5 plus 5 is 0. Square root of 0 is 0. -2 times 0 is still 0. 0 minus 3 is -3. And you can see I have that point right there. There's the point, 1, 2, 3, 4, 5, -3. See him? Okay. Now I know I can take the square root of 1, so I'm gonna plug in -4. Okay, why? Because -4 plus 5 is 1. Square root of 1 is 1. -2 times 1 is -2. -2 minus 3 is, oh gosh, -5. So there's another point. I can go over 4, down 5. There it is, right there. Okay, now I need to know how fast he's going down, so maybe I'm gonna try something else. Plug in, again, anything you want. Now I could plug in a 0, but I'm gonna get 5. That's fine, use your calculator. I don't wanna mess with, I just don't wanna mess with that because I'm not using a calculator right now. So I'm thinking, I can take the square root of 4, I can take the square root of 9 in my head. So you know what, I'm gonna plug in a 4 right there so I can really get an idea of what this is doing. If I plug in a 4, 4 plus 5 is 9. The square root of 9 is 3. -2 times 3 is what? -6. Minus 3 is what? -9. And that gives me a point to aim for. Now I have a feeling I'm running out of my paper on this one, but I hope that gives you an idea. I would go over 4 and down 9, and that would give me this nice smooth curve to aim for. Okay, so look at all the transformations. We have a horizontal shift to the left. We've got a reflection over the x-axis. It is getting steeper by a factor of 2. It's increasing by a factor of 2. So it's happening faster, and it's going down 3. That would be called a vertical shift, 3 units down, okay? So if this was a fraction, let's say I had the same thing, but it was at 1/2, well then it's going down at half the rate, okay? So he would have going down even slower because everything I would have been multiplying it by 1/2. So if it's on the outside, what you see is what you get. I mean, like he's going down 3, he's going up half the rate or twice the rate or whatever, okay? So that's pretty easy. It's when things go on the inside that maybe it gets a little tricky. So, yeah, it does. So let's do another one right here. Let's do this one. If you've got this on the inside, so let's do this. And we'll compare it to this. Okay? If it's on the inside, I still see a square root symbol, so I know we've got my little eyebrow. If he's on the inside, he reflects across the X. So he's gonna look like that, okay? That's all that does right there. So if it's on the inside, it reflects across, I may have said that wrong, but it reflects across the y-axis right there, which means it changes the sign of the X. And we'll do one here in just a minute. You can fast forward if you're like, oh, okay, I got this. Remember, if it's on the outside, it flips it upside down. So here's your standard one for square root. It's the eyebrow, remember? And it would just flip it down here. So if it's on the outside, it reflects across the x-axis, which means you would change the sign of the y. I know, it's so crazy confusing. So there you go, that's that. Now, if you have a value on the inside, this is what's really crazy. Let's say I have the square root and I do this. Okay, that's gross. I'm gonna tell you, remember, if it messes with your x, or messes with your mind, you would think it would take half the value of x. What it's gonna do is it's gonna do the opposite, and it's gonna double the value of the x. I don't know that they give those to you on your homework. If they do, let me know. But I think the easiest thing to do is plug in values. But if you've got a number on the inside, just remember, if it's messed with the x, it does the opposite of what you would think. I don't think they're that cruel to you to put values on the inside. Let me know if they do. I didn't see any. Okay, I did know you have one of these on your homework. And then they want you to take these points and apply a transformation. So what I did real quick is I had some points. These are the points. Now remember, there are infinitely many points on this graph right here. I highlighted, what, 6 of them? There they are, okay? So let's say I start with this graph, okay? But then they want me to do the following transformations. So let's say, I'm gonna make this gross. Let's say they want a negative, and they want you to take, let's say this is the function f of x. So they want you to do x plus 2, and then they want to go minus 3. And they want you to graph that, okay? And you're like, what? Well, first of all, if it was just multiple choice, I could probably pick out my graph. I know that this is going to turn him upside down, right? This is going to make him reflect over the x. I do know that. So it's going to flip him upside down, okay? So I know this means I'm going to change the y value. That's what that means. This means I'm going to go left 2 units, or you're going to subtract 2 from every x value. Okay, this means it goes down 3 units, which means I'm going to subtract 3 from every y. Okay. So you're like, well, what do I do first? Well, let's just take this point right here, the first one. Remember, in order of operations, you do what's inside parentheses first. So the first thing I'm going to do is I'm going to subtract 2 from my x. Well, negative 2 minus 2 is what? Negative 4. Okay, work right outside. That means to change the sign of the y. So instead of a 2, that now becomes a negative 2, and then you're going to subtract 3. So negative 2 minus 3 is what? Negative 5. So I now have that new point that I can graph, okay? And you're gonna do that for every single one. Like, for example, let's do this one. You're gonna subtract 2 from the x. Well, 2 minus 2 is 0. You're gonna change the sign of the y because of this guy. That's gonna make it a negative 6. And then subtract 3. Negative 6 minus 3 is negative 9. You're gonna do that for every single one, and then plot your points, and you will have your new graph.